So hello everyone, for today's video, we will be discussing about ethers. So its characteristics and how to name ethers. So without further ado, let's start. Our topic for today is all about ether. So when we say ether, it is a class or group of organic compounds comprising an oxygen atom connected to either alkyl or aryl groups. So when we describe ether, it is a colorless, high volatile, sweet-smelling, and extremely flammable liquid. So ether is in the form of liquid, but it is very flammable, or it is very prone to fire. And ether, it is commonly used as solvent. So when we say solvent, it is mostly good is in the liquid form. And the general formula for ether, we have here the ROR, which means the R here represents the either alkyl or aryl groups, which bonds to oxygen and bonds to another alkyl or aryl groups. So now we will proceed to the classification of ethers. So there are two classifications of ethers, namely the symmetrical ether and the asymmetrical ether. So first, when we say symmetrical ether, it refers to if two identical groups are attached to either sides of an oxygen atom. So it is also known as the simple ethers, and it has the Greek prefix di. So, for example, in the symmetrical ether, so you have here the diethyl ether and the dimethyl ether. And now we will proceed to the symmetrical ether. So, if two different groups are attached to either sides of an oxygen atom, so the symmetrical ether, it refers to the two identical rather. So in the asymmetrical ether, it refers to the different groups are attached to each sides of an oxygen atom. So it is also known as the mixed ethers. So for examples, in the asymmetrical ether, we have here the methyl phenyl ether and the ethyl methyl ether. So now we will proceed to the next slide, which is the standard rules was introduced by. So it was introduced by the International Union for Pure and Applied Chemistry, or also known as the IUPAC. So there are two standard ways of ether nomenclature or ether naming. So the two standard ways are, first is the common nomenclature or the common naming, and the second one is the IUPAC nomenclature or the IUPAC naming. Now let's proceed to the nomenclature rules of ethers. So there are three most common nomenclature rules of ethers. So first states that nomenclature of aryl or alkyl groups are in the alphabetical order and adding the word ether to its final. So for example, we have here the ethyl. So we have here the ethyl. So and other alkyl or aryl group, rather. So we have here the methyl. So since E comes first from M, so therefore our ethyl here will be the first, and next will be our methyl. So and adding the word ether to its final. So we have here a name which is ethyl methyl ether. So that is the essence of the first nomenclature rule. Now let's proceed to the second. So if there are two the same groups attached are named using the Greek numerical prefix di. So for example, we have here the ethyl. So instead of using ethyl, so we will be using the diethyl ether. So that is the importance of the second, or that is the focal point of the second nomenclature. So instead of using ethyl, so we will be adding the numerical prefix di. So it refers to the diethyl ether or the dimethyl ether and the diisopropyl ether. So that is the second nomenclature rule. Now let's proceed to the third one. So the third nomenclature rule refers to a substituent group having more carbon atoms is chosen as the main parent hydrocarbon, whereas the other substituent group is named by using the suffix OXY. So, during third example is, or the third rule rather, so we will count the number of carbons or the number of carbon atom. So, kung kinsa to ang pinakadaghan carbon or the presence of carbon, himuon na to siya nga main parent chain. And the least one will be our OXY substituent. So, for example, we have here the methyl. And another, we have here the ethyl. Since ethyl has the presence of 2 carbons and methyl has only 1 carbon, so therefore, our ethyl here will be our parent hydrocarbon, which will become ethane. And our methyl here will be our OXY substituent. So, therefore, in naming this, we have here the nomenclature of methoxyethane. So, again, the more carbon atoms is chosen as the main parent hydrocarbon, and the least or the gamay ra siya nga presence of carbon will become our OXY or oxy substituent. So now let's proceed to the next slide. As you can see here, there are table or there is a table. So in the first column we have the number of atom, and the second is the name and the word root. So if there are presence or if there is a presence of 1 carbon, so therefore it will be called ethane, and the word root is eth. And if there are 2 carbons, we have methane, and so on and so forth. If there are 3, so propane, and 4th we have the butane. And if there are 5 carbons, we have pentane. And if there are 6, so hexane. And if there are 7 carbons, we have heptane. And if there are 8 carbons present, which refers to octane, and 9 for nonane, and 10 for decane. So as I only include 10 number of carbons. So napanin sila mga sumpay, so 11, so on and so forth. So next slide will be the examples. So in this example, it was written in the line angle structural formula. So in this example, we have to again count the number of carbons. So 1 and 2, and in the right side we have 1 carbon. So in the vertices of each angle, we have the presence of 1 carbon. So in the left side rather, so we have here the 2 carbons, and in the right side we have only 1 carbon. So therefore we can now conclude that in the right side it is our oxy substituent, and on the left side will be our main parent hydrocarbon, or in this section. So again, there are 2 ways of naming naming ethers: the common name and the UPAC name. So if there are 2 if there are two carbons present, so we can call here as a ethyl. And if there are only one carbon, so we have here methyl. So since ethyl comes first from M, so therefore we have here the common name of ethyl, methyl, and of course adding the word ether to its final. So the common name for this structural formula, we have the ethyl, methyl, ether. And how about the IUPAC name? So since we have already assumed that in the methyl, it is our oxy substituent. So therefore, it will become, or it will be changed into methoxy because of the presence of oxygen. So methyl will be changed into methoxy, and our ethane, or the ethyl here will be our main parent chain that will become ethane. So therefore, our IUPAC name is the methoxyethane. So now let's proceed to another example. It is also written in the line angle structural formula. So in this example, we all count the number of carbons. So again, count the number of carbons, 1, 2, and 1, 2. So since there are two equal number of carbons, so it refers to the symmetrical ether. Or again, if there are, instead of using it ethyl, so we will use the diethyl ether. So it is your choice on what you are going to put this as your oxy substituent. So I choose the right side, and you can also choose the left side since there are equal number of carbons. So the common name for this example is the diethyl ether. And for the IUPAC name, we have, since ethoxy here is our the ethyl here is our oxy substituent, since there is a presence of carbon. So now we already conclude that in this section is our ethoxy, and the ethyl here will be our parent chain. So it will become the IUPAC name of ethoxyethane. So let's proceed to another example for you to understand deeper. So again, count the number of carbons. So 1, 2, 3, and 4. Each vertex has the presence of carbon. And in the right side, we have 1 and 2. So if there are 4 carbons present, so we called it as butane. And if there are 2 carbon present, so we have here the ethane. So since ethyl here is our having the least number of carbons, so therefore it will become our ethoxy, or the OXY substituent, and our butyl here will be our main parent chain. So since B comes first from E, so therefore our common name is the butyl ethyl ether. So the butyl ethyl ether. And for the IUPAC name, so since ethyl here is having the presence of oxygen, so therefore it will be called as ethoxy, and the butane here, so it will become ethoxybutane. So now let's proceed to another example, which is another example of a line angle structural formula. So first, again, count the number of carbons. So 1, 2, 3, 4, and 5. So, and as you can see, the presence of oxygen lies in the third vertices, or the third vertex. So now the common name for this, we have here the ethyl pentyl ether. So pentyl here, so it refers to the pentyl refers to the 5, since there are 5 carbons. And for the IUPAC name, it is quite different to the recent example, since we have to use, since naaman siya ay mga vertices diri dapita and diri dapita. So in the IUPAC name, so we have to use the 3-ethoxy 2-methyl pentane. So since for ang explanation for this one is, si our ethoxy kay ni belong siya sa third nga vertices, or sa third nga vertex. So mao na siya nga si 3-ethoxy. And si 2-methyl, si na siya what do you call this? Na siya connected diri nga another compound. So therefore the 2-methyl, so since there are 2 carbons, so 1 and 2, so 2-methyl pentane, and pentane refers to 5 carbon. So I know that you are confused in the fourth example. So we have here another example. So in this example, we have here the ethoxy, or the OXY, or the oxy substituent. So in this common name, so we have to count the number of carbons. So 1, 2, 3, and 4. So since the number of the common name will be the butyl isopropyl ether. So since there are 4, which refers to the butane, and for the isopropyl, so in this kani siya nga formula is mostly refers to isopropyl. So if there are kanang nagsanga siya nga example, so the common name is the butyl isopropyl ether. And for the IUPAC name, we have the 1-isopropoxy 3-methyl butane. So that is the IUPAC name. And now let's proceed to another example. So my corrections, we have here the CH2 here. Technical error lang na siya sa paghimo o PowerPoint. Then since again count the number of carbons, so we have 1, 2, 3, and 4. So since in the right side in the left side rather, there are only one carbon, so our common name will be methyl propyl ether. So since there are so my corrections, so again, so our ang pag-ihap na to is from the gikan siya sa bond ni oxygen. So 1, 2, so 3. And in the left side, only one, there are only presence of one carbon. So that is why the methyl propyl ether. So since there are threes, that 3 refers to propane, and that is the propyl ether. And for the IUPAC name, we have the methoxypropane. And now let's proceed to another condensed structural formula, and our count the number of atoms. So 1, 2, and 1, 2, 3. So in this side will be our main parent chain. So main parent chain, and the left side will be our oxy substituent. So 2 carbons refers to ethyl, and there are 3 carbons refers to propane. So our common name will be ethyl propyl ether. And for the IUPAC name, we will have to use the ethoxypropane. So ethoxy with the presence of oxygen, and ethoxypropane is the IUPAC name for this example. Now it's your turn, so try to name me. So I have here 2 examples for you to answer, and you can pause the video for you to test yourself. So my correction, so in the next example, we are also technical errors. So we have C bonds to another H in this example. So now let's proceed. The common name and the IUPAC name. So in the first example, we have the dimethyl ether, and the IUPAC name is the methoxymethane, and the common name and the IUPAC name for the second example is also the dimethyl ether and the methoxymethane. So as you can see, they are only the same, but as you can see on how they was written was only the difference. So maybe this one is the line angle structural formula, and this one, it was the expanded formula.
So good day everyone, I am Neljun Tabaransa, and I will discuss the topic about the drawing structural formula of ethers, the expanded structural formula, the condensed structural formula, and the line angle formula. So here is the example of ethers, the ethyl methyl ether. So this is the expanded formula, or in other terms, it is the Lewis structure. So the formula of ethers, by the way, is ROR. So the formula of ethers, by the way, is ROR, which means the rest of the molecules. So this R refers to this any chain of carbons, and this. So this oxygen is the central atom. So next is the condensed formula of ethyl methyl ether. So these two carbon, this and this, is simply means here, and the last other carbon is this. So ethyl methyl carbon is composed of 3 carbons bonded to oxygen. So the other one is the line structure formula. So this is the line angle formula. This is what we call first carbon, and the last one is 2. Okay, and the other one is the third carbon. So that's what the process of making a line angle formula of the ethers. And the same way to the other organic compounds, this is how we make a line angle formula. So let's proceed to the other example. So this organic ethers names ethoxybutane. Name ethoxybutane. Ethoxybutane. So the expanded formula of ethoxybutane is composed of 4 carbons, since butane is composed of 4 carbons. So this is the butane, and the other one is this ethoxy because it is the oxy substitute, and because so this part is named as an oxygen substituent, wherein this ethyl, the suffix "il" will change into oxy, and that's what becomes an ethoxy. So in the naming, it becomes an ethoxybutane because the oxygen substituent should be first, and the next is the butane according to the IUPAC nomenclature. So we'll proceed to the other method, the condensed formula. So since carbon is composed of 4 carbons, right? This is 1 carbon, 2 carbon, 3 carbons, 4 carbon, butane rather. So this is the butane. This is the butane. This is the butane, and the other is the ethyl or the ethoxy group. So in the line angle formula, okay, now here, this is 1 carbon, 2 carbon, 3 carbon, and 4 carbon, which is the butane, and there 1 carbon, 2 carbon, which is the ethyl or the ethoxy, as this is the oxygen substituent. So let's have the other example. Here in the methoxyprofane. So methoxyprofane, its expanded formula is, since methoxy is the oxygen substituent of the methyl group, methyl, since methyl composed of 1 carbon bonded with the oxygen, or CH3, because of CH3. So this is the methyl or methane group, and this is the methane. Same na siya, methane methyl. So here in the other part is the propane. Propane is composed of 3 carbons. Like methane composed of 1 carbon, propane composed of 2 carbon. Wait. Again, methyl composed of 1 carbon, ethane composed of 2 carbon, propane composed of 3 carbons, and butane composed of 4 carbons, and so on. So the contents formula of the methoxypropane is this. So here is the contents formula of the methoxypropane. So this CH3, or the 1 carbon here bonded in the oxygen, that is also called as an oxygen substituent. So this is the methyl group. Then here on the other side is the propane group, composed of 3 carbons, 1, 2, and 3. So in the line angle formula, so here, this is the 1 carbon or the methyl group. The other one is 1, 2, 3. There are 3 carbon here, which is also the propane. So in the naming nomenclature or IUPAC naming, this oxygen substituent will change into, the methyl group will change into, the suffix of the methyl will change into oxy. That's become a methoxy. And this, the propane, it becomes a methoxypropane. So that's all about the structural formula of ethers. So here are another example, by the way, the diethyl ethers. So this is the example of diethyl ethers. So when we say di, it is composed of 2. So meaning they are symmetric. They have the same compound both sides. So here we have 2 carbons. Since ethane is composed of 2 carbons, it becomes an ethyl. Then here's the picas, 2 sets of carbon. That's made the diethyl ether a symmetric compound or symmetric ether. So same as condensed formula, it has 2 carbons here. So wala na lines to dawag tagang na diri ang mga lines. So sa line angle formula, here 2, 1, 2. This is the ethyl group and the ethyl group also. So that's all. So that's all about the drawing structural formula of the ethers.